Okay, let's unpack this.
Mhm.
Today, we are diving deep into something pretty fundamental in modern building. We're talking about the critical components, often invisible, that make those sleek glass towers and efficient homes actually possible.
We are. We're talking about architectural standard aluminium sections.
Right. The bits and pieces you don't always notice.
Exactly. They're essentially the pre-engineered building blocks. Think of it like this. If a building's the body, these profiles are kind of the skeleton, the structure, maybe even part of the skin.
Okay.
They're exact, repeatable shapes that let builders put up massive structures quickly, precisely, and importantly, efficiently.
So our mission today is to get past just the technical side, the jargon, and really understand why. Why is this reliance on standardized pre-engineered aluminum so indispensable now? This deep dive is basically your shortcut to getting smart about these, well, smart construction solutions.
hmm And just to set the stage clearly, when we say standard section, what does that mean? It's an aluminium profile, mass produced to a spec everyone recognizes. It does a specific common job, either structural or maybe aesthetic.
And crucially, it's not custom made for that one project.
Precisely. That's the key distinction.
In that contrast, it's absolutely vital for the economics, isn't it? I mean, if you need something custom, you're paying for extra design time, maybe prototypes, definitely unique tooling.
Oh, yeah. The costs add up fast.
But with a standard section, it's like off the shelf,
Yeah.
ready to go, engineers already trust it, and you can use the same profile across tons of different projects.
Exactly right. And then there's the material itself, aluminium. That's the other half of why this works so well.
It really is the champion material for this, isn't it?
It really is. You're talking about something incredibly lightweight. Think about what that means for the load on the building's foundation, much less stress.
Huge difference.
And it's highly resistant to corrosion. I mean, that's essential for anything exposed to the elements, right? Plus, it lasts for ages.
And you can't ignore the sustainability angle these days. How does standardized aluminum fit into that whole green building movement?
Well, it fits perfectly. Aluminium is 100% recyclable. And unlike a lot of other materials, you can recycle it over and over again without it losing any quality or strength.
That's amazing. No downcycling.
None. So when architects spec standard aluminium profiles, they're choosing something that already supports a closed-loop life cycle. It makes hitting those green building certifications, like LEA, much easier.
So it's that combination, the efficiency, the strength, and the recyclability. That's why it often wins out over steel or, say, vinyl.
That's exactly it. It ticks all the boxes for modern construction needs.
Okay, here's where it gets really interesting for me, because all that efficiency, it really comes down to the shapes, the geometry. Looking at standard sections is like looking at an engineered geometry toolkit.
That's a great way to put it.
The versatility comes from having just the right shape for the job, whether that's holding up weight or just looking sleek.
That's absolutely right. Every angle, every curve, every little hollow space inside, it's all been calculated for maximum function. Let's go through the toolkit, maybe look at the most common shapes and what they actually do.
Sounds good.
Okay.
Let's start simple. What's the most basic profile? Maybe something you'd see at a corner or where two things join.
Okay, we'd start with angles. Simple L-shaped profiles. They're indispensable, really, for protecting corners, adding rigidity to joints, creating those nice, clean, sharp edges in frames.
Like around windows and doors.
Exactly. Places where you need things to line up perfectly. Simple shape, but structurally vital.
Okay, so the angle handles the corner. What if you need to, I don't know, run something through the structure, like cables or maybe a track for something to slide on?
Ah, right. That's where channels come in. They look like a C. They're great for framing, too, but that open side is, well, it's their superpower. That open channel gives you easy access. You can install sliding tracks in there, slot panels in, or even use it as a neat little trench to run wiring or maybe hydraulic lines right inside the frame itself. Very handy.
Clever. Okay, what if you need to make a grid or divide a space and you need support balanced in, like, two directions?
Then you'd probably reach for the T-sections, shaped like a T, obviously. They're fundamental for creating grids that carry weight or for internal dividers.
Ceiling grids.
Ceiling grids are a classic example, or complex office partition systems. Because the T is symmetrical, it gives you balanced support, both vertically and horizontally.
Makes sense. Okay, we've covered inside supports and joints. But outside thinking roofing, facades keeping the weather out is paramount.
Yeah.
Is there a profile specifically engineered for that, for overlap and water runoff?
Yes, definitely. That's the job of the Z sections. Z-shaped profiles, they are absolutely critical in roofing and cladding systems. That specific zigzag shape is designed to create the necessary overlap between panels.
Ah, so the water runs off properly.
Precisely. It helps ensure the whole facade acts like a single impermeable barrier against wind and rain. Really important stuff.
Now let's talk scale.
Yeah.
Pure structure. When you get into multi-story buildings, people often think of massive steel beams. But aluminium has its own heavy lifter, right? The I-beam.
It does. Aluminium I-beams, they're famous for their, let's call it an engineering trick, an incredibly high strength-to-weight ratio.
Okay.
So you use them in major structural parts, floor systems, roof trusses, anything spanning a large distance. And the insight here, architecturally speaking, is that this lightweight strength is partly what allowed designers to create those amazing soaring glass facades you see now.
Because the frame itself isn't adding enormous weight.
Exactly. The structure can support the glass without carrying the huge dead weight of traditional steel. It really changed what became structurally possible. It opened up design possibilities.
Wow. Okay. And finally, what about that clean, modern, almost minimalist look? The simple box shapes we see everywhere.
Ah, you mean the square and rectangular tubes?
Yeah.
Yeah, they're hollow profiles. Their inherent strength combined with that clean geometry makes them a favorite for structural supports that are actually visible.
Like railings.
Railings, yes, modern fencing, even frameworks for custom furniture. They give you the structure you need, but keep the look really sleek and uninterrupted.
So that's the toolkit of shapes. An amazing range. Now, let's shift gears and talk about the practical benefits. Because every builder, every architect, they're all under pressure for speed, for cost savings, for sustainability.
Always.
And it seems like standardization is the engine driving all three. You mentioned 4 pillars of efficiency.
That's right. Let's call them the 4 pillars of standardized efficiency. Pillar 1 is design efficiency. Think about it. If an architect knows exactly what an angle profile is or a specific channel section, and they know its load capacity.
They don't have to reinvent the wheel each time.
Exactly. They don't waste time designing it from scratch. They can rely on these predefined, universally understood shapes and sizes.
It sounds almost like building with, I don't know, industrial-grade Legos.
Yeah.
You know the piece fits, you know it's strong enough. You don't have to worry if your drawing of a channel will actually work in the real world.
Precisely. That trust, that consistency, it means structural elements fit together seamlessly. It cuts down on design clashes later, improves accuracy. It just speeds everything up.
And that speed leads right into pillar 2, I imagine.
Perfectly. Pillar 2 is cost effectiveness. Because these sections are mass produced, and we're talking huge global economies of scale, they are just vastly cheaper than commissioning a one-off custom part.
Right.
You completely eliminate those big costs tied to prototyping or making specialized tools just for one job.
That's a double win cuts, design time, and material cost.
Yeah.
Huge financial incentive.
So pillar 3 must be about speed on site during the actual construction.
Absolutely. Pillar 3 is ease of installation. These sections arrive on-site pre-sized, ready to basically slot into place. That drastically reduces the on-site labor needed.
Which is often the most expensive part of a project. Often, yes. There's very little need for extensive cutting or reshaping on site. And this also means standard components integrate perfectly with modern methods like modular building or prefabrication.
Ah, so it supports that move towards building sections off-site and assembling quickly.
Perfectly. It enables that rapid deployment you need for large-scale projects with tight deadlines.
Okay, and the final pillar, we circle back to longevity and the environment.
That's pillar 4, durability and sustainability. We touched on the corrosion resistance earlier. That means the structure lasts for decades with minimal upkeep. And by using standard aluminium, you're essentially future-proofing the building, both structurally and environmentally. It helps tick all those boxes for green standards like LEBD.
Got it. So we have the shapes, we have the benefits. What does this actually look like out there when we look at the skyline or even our own homes? Let's talk real-world applications. Where are these profiles doing the heavy lifting?
Well, they're really the backbone of modern cityscapes. In big commercial projects, they're essential for things like glazing systems and especially curtain walls.
Explain curtain walls for someone visualizing this.
Sure. A curtain wall is that outer skin, usually glass and aluminum, that you see on most modern multi-story office buildings or hotels.
Yeah.
It doesn't actually hold the building up, that's the internal structure.
Right, it just hangs like a curtain.
Exactly. And the lightweight, strong, corrosion-resistant framing provided by standard aluminum sections is what holds those huge panes of glass in place, defining the whole look of the building.
Okay. And closer to home, residential buildings.
They offer great functionality there too, particularly in doors and windows. Standard aluminum frames allow for those really slim, strong sightlines that look so modern.
Yeah, you see that a lot.
And the clever engineering within those profiles, the specialized shapes, they create chambers and seals for really good thermal and acoustic insulation. They're also great for lightweight interior partitioning, dividing up spaces in open plan homes without adding bulk.
Right. And even in more rugged settings,
Yeah.
industrial.
Absolutely. Industrial infrastructure needs durability and strength above all. Standard sections form the structural frameworks of huge warehouses. They're also used to build mezzanine floors.
Those internal raised platforms.
Yeah, exactly. You see them in warehouses, logistics centers. They need to hold a lot of weight, but they also need to be installed quickly and maybe even be reconfigured later. Standard aluminum sections are perfect for that strong, light, modular.
The level of engineering really comes through when you look specifically at doors and windows. You mentioned manufacturers don't just offer one frame type. They have whole series for different needs.
That's right. This is where it gets quite specialized. For instance, you might start with the classic €1 series. That's your traditional, pretty cost-effective, lightweight profile. Good for internal doors, partitions, maybe sheltered areas.
Okay. But if you're building, say, a modern house aiming for high energy efficiency, maybe with big glass panels.
And you'd likely move up to the 60mm series. This
Yeah.
is a more modern evolution. The profile is deeper, physically bigger.
Why is that important?
That greater depth lets it hold wider, much heavier glass panels, double, even triple glazing for insulation. And the engineering focuses more on things like multi-point locking systems, better seals for air, and water tightness. It's built for energy efficiency and handling bigger structural loads.
Interesting. And I heard there are series named after regions or standards, like Damal or Gulf.
Definitely. The Domal series, for example, draws inspiration from European standards. What often makes it special is its internal structure. It has multiple chambers inside the profile.
What do the chambers do?
They create thermal breaks. They interrupt the path heat would normally take through the metal, giving you really excellent thermal insulation. Critical for cold climates or meeting tough energy codes. It's seen as a premium thermal product.
Makes sense. And the Gulf series, that sounds specific.
It is. Engineered specifically for places with extreme conditions, think coastal areas. High humidity, salty air.
So tougher.
Generally, yes. Typically features enhanced wall thickness in the profile, maybe superior surface pretreatment to really fight off that salt air corrosion. It's often specified for high-rise buildings or luxury projects right on the coast where standard materials might degrade much faster.
And beyond just the frame types, there are other specialty applications, right?
Yeah.
Like louvers.
Yes, louvers for controlled ventilation or providing shade. Also, the bifold series has become hugely popular.
Oh, the doors that fold completely open.
Exactly. That's where the precision engineering of standard yet robust components allows for this big architectural trend. You need strong, flexible parts working together perfectly to create those wide openings, letting a whole wall of glass just fold away smoothly. And it has to work reliably for years. And this reliance on precise standard profiles means the supply chain globally is very strong. You see major manufacturers, including leading companies from India, supplying these components worldwide. It ensures builders everywhere get consistent quality, meeting tough international standards.
It really is a powerful concept. Okay, here's the final thought we want to leave you with today, something to kind of chew on. This reliance on mass-produced, standardized parts. Paradoxically, it seems to allow architects more creative freedom, not less.
It sounds counterintuitive, maybe, but it's true. Because that standardization means the basic structure, the bones of the building is reliable, it's proven, it's cost-effective.
Right.
That stability frees up resources, it frees up budget, it frees up design attention to focus on the really complex, artistic, unique elements. Things like bespoke curved facades, maybe unique roof shapes. These often rely on specialized profiles, sure, but they're built around that dependable framework of standard aluminum.
So the next time you find yourself looking up at some really cutting-edge, complex piece of architecture, maybe reflect on how often the most critical load-bearing bits holding it all together are actually these simple pre-engineered blocks, mass-produced to perfection.
It's the standard that makes the spectacular possible. A reliable foundation really does allow for almost unlimited innovation on top.
A great place to leave it. That's it for this deep dive.